Hello, Professor. This is Yvette Starks, and today this experiment is based on forces and motions and how do they apply to dominoes. Force makes things move, or more accurately, make things change their motion. Two natural forces that we have experienced are gravity and magnetic forces. Gravity is the main thing that makes the toppling domino experiment possible. This force pulls a knocked over domino toward the earth, sending it crashing into the next domino and setting off a chain reaction. When you pick up a domino and stand it upright, lifting against the pull of gravity, you store some potential energy in it. As a domino falls, energy is converted from one form to another. This change creates a chain reaction, causing domino after domino to topple. There is another important force that acts on toppling dominoes, which is friction. This slowing force comes into play whenever moving surfaces make contact. Falling dominoes create friction as they slide against one another and when their bottom edges slips against the ground. Plastic dominoes on a polished floor can be very slippery. They are going to topple differently than wooden dominoes on a rougher surface. The steps are as follow. The steps to the experiment are as follow. Standing a domino upright gives it potential energy or stored energy based on its position. Step 2. When the domino falls, much of its potential energy is converted into kinetic energy or energy of motion. Step 3. Falling dominoes slide against one another and their bottoms slip on the surface they are on. Both movements create friction. As a result, some energy is converted into heat and sound. So today I am going to do the domino effect, and then I'm going to explain to you how the energy transfers into the next. The unmoving dominoes have inertia, a tendency to resist motion when no outside force is pushing or pulling on them, but a single nudge is all it takes to push the first domino past its tipping point. When that first domino falls, the potential energy stored in it becomes available to push onto the next domino. As the first domino falls, much of its potential energy converts to kinetic energy, the energy of motion. Some of that energy is transmitted to the next domino, providing the push needed to knock it over. Energy continues traveling from domino to domino until the last one falls. The physics which affects change of falling dominoes are subject to measurable physical force, including gravity, momentum, and force vector analysis. The reaction is affected by the size and mass of the domino as well. As a result, determining the optimal rate of a domino cascade reaction requires mathematical analysis. The time between impacts is affected by a domino standing closer to the first row in a row would be struck sooner than the position farther away. Therefore, the rate of the domino topple will be affected by how close the dominoes are placed. As a domino begins to fall, it moves slowly, impacting the next tile in the row with little force. So now I am going to tip over the domino to allow you to see the force and motion in action. And this is so funny because I haven't done this in years. So here you see a stack of dominoes. Well, you see dominoes gently placed separately, maybe about 1.5 inches to 2 inches apart from each other. And we're going to start here with the left domino being the first domino. And we're going to see if my experiment works. 1, 2, 3. It works. So with that being said, the distance between the tiles affects the magnitude in which each tile hits the next one and therefore affects the entire chain reaction speed. Variables affecting the speed of a domino chain reaction. The amount of the time between impacts, how much force each tile applies to the next, and the velocity a tile hits the next in the line is affected by the distance between the tiles is considered measuring the cumulative effect. Therefore, the key question is what distance and what angle will a falling domino apply the greatest amount of force to its adjacent tile to topple an entire row of dominoes. I hope my experiment was interesting to you. It was quite fun to do myself. And thank you for watching. Bye.